My name is Scott Hunter, and I am the Director of Program Management at Microsoft on the .NET platform. This ASP.NET stuff is actually really fun because I joined Microsoft in 2007, and the first, all my career up until earlier this year, I've been working on the ASP.NET team. And so today we're here to talk about ASP.NET Core. And this project actually started about 3 years ago. At the time, it was called ASP.NET 5. And the reason that as a team, as the web team, we were looking at .NET and ASP.NET and trying to figure out how do we make ASP.NET more successful than it is today. And we identified a couple of things. If I look at the competition that I have out there, I've got Node.js, I've got Java, I've got a variety of those folks. They're all open source and cross-platform, and we were not. And so we took a chance to go and take ASP.NET and reimagine it as an open source cross-platform framework for building modern web apps. And along the way, it was renamed from ASP.NET 5 to ASP.NET Core 1. The reason we did that, and I think it's important for people in the room, when we first started, the idea that ASP.NET 5 was the latest version of ASP.NET and it replaced ASP.NET 4 was not something we wanted people to think. I mean, the reality is there's a ton of my customers on System Web, which is ASP.NET MVC today, Web API, SignalR, Web Forms. Those are all great tech and do awesome. But this is not the replacement for those things. This is a reimagined version of ASP.NET with a little different feature sets in some cases, a lot of compatibility in some cases. And as we talk today, you'll see why we built this. So first off, as an ASP.NET guy, I wanted ASP.NET to be totally modular, meaning that I don't just bolt on every feature by default. I want customers to be able to say, I want to use this much ASP.NET or this much ASP.NET. Today, with System Web, you just basically use System Web, so you don't get that choice. And so we've rebuilt it, and you're going to see in some of the demos how you can basically build up and turn on or off any of the individual components of ASP.NET. The second thing is ASP.NET. The web is a fast-changing place. I mean, if you look a couple years ago, jQuery was all the rave, and now if you talk and you look at some of the other talks here that John Papa and Dan Whalen are doing, AngularJS and React are two popular web client frameworks. So the web moves very quickly, and we want ASP.NET to move very quickly with them. So by breaking it out of the .NET framework, we can ship a lot faster. I want to make it very easy to take applications and build them and move them from on-premise to the cloud. And so there's a lot of stuff in ASP.NET Core that's all around how to build apps and make sure that when you move them to the cloud, that's a seamless thing. Once again, as part of the open source cross-platform thing, I want anybody to be able to go grab a Linux box, a Mac, download something, use the editor of their choice, and use the tech. And they're, of course, fast. If you were in my session earlier today, we talked about the fact that ASP.NET is much faster than Node.js, much faster than Go, faster than many of the Java frameworks. And so we want to make the tech awesome. This is kind of new, and this is interesting. If you want to try .NET Core, we have a new website. And the way that I reference the website is you just go to dot.net. And by going there, here's the new site. And you can click the download button, and you can see we've got downloads for the variety of platforms that you might be on. Windows, Linux, Mac, we got you covered. Our docs, we have a brand new docs site, and this is pretty awesome as well. So if you want to read docs about ASP.NET, it's docs.asp.net. The nice change about the docs is all the docs live in GitHub now, and they can be published almost in real time every day. And so there's a ton of great content here. Highly recommend coming here. Tutorial to get started with here. A lot of MVC stuff, good stuff. And then we have a GitHub account that has a bunch of samples inside of it as well. So you can go to all three of those places to get started with ASP.NET. If you look at how things stack in the world today, this is kind of how I would actually picture this. And you'll notice we've got System Web over on the left side here. It's got Web Forms, MVC, Web API, the big frameworks that we built on top of it. And it is a Windows component, and it only runs on top of the .NET framework that ships as part of Windows. You'll notice over here that .NET Core and ASP.NET Core is a little different. ASP.NET Core actually can run against the full framework or .NET Core. So you don't have to feel like, if you want to try ASP.NET Core out, you don't have to not use .NET Framework. If you want to be .NET Framework based, you can do that. And you'll see that on top of ASP.NET Core, we have MVC. I actually don't call it that anymore. It's back to just being one product for me, but that's the way we actually have it here. Here is some of the big kind of high-level things that we have here. We built a brand new web server called Kestrel that is our cross-platform web server. And even if you're running on Windows, you're actually running behind Kestrel. And Kestrel's pretty cool because it allows us to let you run ASP.NET bare metal. If you don't want to run it with a web server, you can run it with Kestrel on the box by itself. We have a new mechanism where in the past, ASP.NET was just booted up by IIS. There were some magic hookings into ASP.NET, and ASP.NET would boot up via basically magic. And I'm going to show this. In ASP.NET Core, we give you full control of this. So ASP.NET Core applications are kind of interesting. They're actually console apps that actually boot up the web stuff. And then we took a bunch of the features in ASP.NET today, and we broke them into what we call middleware. And so each of these components that I show here, routing, how we actually convert a URL to a controller, authentication, how we let you sign in, static files, diagnostics, error handling, all of these things are now what we call middleware. And any middleware, you can actually decide if you want to use these things or you can stitch them all together. And so this is part of that modularity that we have in the platform. The next thing is we built dependency injection directly into ASP.NET Core, which is pretty cool because it means dependency injection is part of the entire system. And I'll show in some demos later on, even Razor, you can actually inject objects directly into Razor markup files as well. So all the way through and through, brand new dependency injection. Configuration. Configuration is an important thing. So we've been web config based for a long time. That's an XML configuration model. As part of thinking of the cloud, we wanted to change the configuration engine. So we've got a new config engine, and it supports doing a lot of things. One of those things is it supports environment variables, being able to override the file, so you don't have to have those XML transform files anymore. It supports third-party plugins, and so in the future for Azure, we'll let you be able to use the Azure Key Vault to store some of your configuration. So that's built into the system. Another thing, if you've ever used logging in ASP.NET today, web forms logging was kind of built in at the base. When we built MVC and Web API, those things didn't have logging all through them. And so when we decided to relook at the framework, we said, hey, let's go take logging and build it in the base of the system all the way through. So everything has got logging built into it. And then obviously, we've got MVC that runs on top of ASP.NET Core today. We have identity for signing in and stuff like that. We have SignalR that'll come out next year. And technically, the MVC inside of here actually does Web API as well. So we actually have pretty much all of the main programming models that exist in ASP.NET Core. The one thing that doesn't exist in ASP.NET Core is web forms. And it's not likely to come into ASP.NET Core. That's mainly because web forms is so tied to system web. If we actually broke it out of system web and tried to put it into ASP.NET Core, we think it would be so different by the time you got to it that it wouldn't actually behave the same way, meaning it's not compatible. And so I don't think that's a good fit. And so we didn't go that direction. That said, web forms will continue to exist. And Jeff Fritz, who's here today and doing some talks this week, he actually works on web forms and is actually building new features like Angular support and stuff like that for web forms. This is really what kind of drove some of the ASP.NET Core stuff as well. These are the three frameworks that we had that we built over time. And what's interesting about these things is you would think that we had one ASP.NET, but these two things, web pages and MVC, both shared Razor pages. They both had their own implementations of HTML helpers, so there was two different ecosystems of stuff there. This is where it gets really weird. If you wrote a controller in MVC and you wrote a controller for Web API, in your mind you might think they're the same, but they are actually two completely different stacks. And they share some code, but they're different. Actions, same kind of thing. MVC actions and Web API actions are completely different code bases. Filters the same way, model binding, and DI. So what you kind of see here is kind of a mix of a bunch of stuff that's not as consistent and common across all of the stacks as they should be. When you think of ASP.NET Core, you merge all of those things together into a single framework. So they're all sharing the same logging, they're all sharing the same routing, they're all sharing the same controllers, they're all sharing the same dependency injection. That's kind of one of the goals we had as we started building ASP.NET Core. So as you see here, one set of concepts. We take all the duplication of having 2 different routing systems and 2 different DIs and 2 different controllers. We move all that and make that very consistent. We also say that we take Web API and MVC, which used to be separate things, they're actually merged into a single concept now. So your controller can actually have Web UI in it, or it can actually do APIs all in the same controller. You don't have to have separate controllers for these things. ASP.NET Core, and all these things are built on top of ASP.NET Core, which also supports .NET Core. And once again, as I was saying before, it supports IS or self-host. You can run it bare metal. It's got the deep integration with DI, and one of my favorite features, which I'll dig into later, is tag helpers. Okay. So I think the best way to think about ASP.NET Core is to kind of start off doing something from scratch. So let me come out here. Make a folder. Okay. So in the .NET Core world, I can build .NET Core applications either in Visual Studio, or I can build them from command line. And I'm going to show kind of a mix of both, just to show that we support both things. The reason we have the command line, obviously, is we want to support the cross-platform. And so to build your first .NET application after you install the SDK, you just run .NET new. I can then do .NET restore. That will take all the packages that I need and bring them back down for me. And then I can do .NET run. Now this is not going to be exciting because this is basically a console application that says hello world. So let's load up Visual Studio Code and let's turn this into a web application. As I was saying before, web applications in this world are actually console applications. So what I'm going to do here is, first off, here's project.json, and this is the place that you actually go in and add the libraries that you actually depend on. And so in my case, to build a web application, to convert that console application to a web application, I need to add a package here. So we'll do Microsoft ASP.NET Core, and then I'll do server, and then I'll do Kestrel. That's our web server. And then I need to pick a version of that. So we'll go with 1.01. So I've added my, as I save that file, I'm in Visual Studio Code, and I said I'll switch to VS in a second, but you'll see Visual Studio Code is actually kind of smart and understand what's going on here. It's like, hey, you changed your project.json, do you want to do a restore? I'll say yes, and you'll see it actually go out there and grab that file item for me. So now I've got a server in my application, and we can go about turning this into a ASP.NET app. So we'll push this down a little bit. And the first thing I need to do is I need to boot up the web framework. So let's create a host. So I'm going to create a web host builder. And this is, the web host builder is the stuff that actually will go and let me assemble all the components to make a web app actually run. And this is where you're going to start seeing this modularity that I was talking about before come into play. So I'll come here, and once again, VS Code, just like VS, will actually give me, help me figure out what I need to make that work. So now I've got the hosting namespace in here, and I'm good to go. So let's slowly turn this into a web app. So the first thing I need to do is I need to go add a server. So I'm going to say use Kestrel. And Kestrel is my web server that actually runs everywhere. And then the next thing I need to do is I need to actually tell it what code to run for my web application. I don't have MVC in this application. This is just bare metal. And so I'm going to call the configure method. And it wants a web host builder. And really what this really wants is it wants the stuff to go find and start up my application. Normally, it would actually run a startup method, and I'll show that later. But right now, I'm just going to go and say, let's put the app directly in here. So we'll create an app here like this, and write some code here. There we go. And now I got my Lambda here set up so I can actually run some code, and I'll say app.run. And then I'm going to give it the actual code that I want to run. So I'll say context equals context. And I'll do response, because I'm going to write out to the web app. And I'll do write async. And I'll say, hello, dev intersections. Okay. So now I've got a couple of these things that need some help. So let's see if the tool will help me. I need a core builder. I need response. I need that. Actually, don't do that. Missing something still. What am I missing? I think I want help on this guy. Let's try that one more time. There we go. Okay, so now that I've got that built, I'm going to tell it to build the pipeline. And I've got a pipeline that's ready to go. And now all I'm going to do is I'll come over here and I will tell the host to run. Like that. And for grins, let's just go back here. And you'll see that actually, let's do that. I left a semicolon off somewhere. And I guess it's there. There we go. I can run it. And I actually have an app running now. That was what, localhost 5000. And the point I'm trying to make here is this is showing the modularity. There you go, hello dev intersections. The idea here is I built all this pipeline manually. If you're doing ASP.NET today, IIS just boots a bunch of stuff up for you, and you don't even know how this even starts. So let's take this to the next level. I'll shut it down, and let's create an app in VS. So we do the same thing here. File, new project. We select ASP.NET Core on .NET Core. And I'm going to build an empty application here. And we're just going to add some stuff to this as we go. So this app's going to look very similar to what you just saw me build, but a few things are going to be a little different. So let's go to the program CS, and let's walk through these things one by one. So here's the same web host builder that we just built before. Now I said use Kestrel. That's my web server. And now there's this use content route. This is actually me telling the application where the files are. And so it's telling me where all the files are in the project, so it knows how to go. And then there's this use IIS integration. ASP.NET Core supports running in IIS or outside of running IIS. What the use IIS integration does is it sets up a middleware for us, or some code for us, that knows how to actually run behind IIS. So we have a module inside of IIS, and when this is turned on, IIS will actually talk through its module to my ASP.NET Core application, and they'll talk to each other, and that's how the IIS integration hooks up. Now, this is where things get interesting. The next line is use startup. In the previous one, I just told it to run and run my request right away, right in this place. But in this case, I'm saying use startup, and I give it the name of a class. And that's where things get kind of interesting here. So instead of writing that lambda like I wrote last time, now there's a class, and inside that class, So my class is called startup. That's the glue that wires these two things together. And now there's a configure method that we look for in this. And you can see that same application builder that I just did is there, the hosting environment. I mean, if we press on this, you're going to see this, my application name, there's my root path, my web root path, all those things we were configuring in the previous step I'm getting access to. I get access to a logger. As I said, logging is built into the base of the platform now. And then a couple things happen here. First off, you're going to see that I tell the logger, I want to log to the console by default. Then I say, if the environment is development, use a developer exception page. Once again, the tech is totally modular. And by modular, what I mean is, if you don't want to develop, you don't want an error page, don't have one. And so you'll see that there's a developer exception page here. And then basically, I app run, and you see something very similar to what we wrote in the previous application. I've not booted an MVC up or anything at this level. I've just done some super small stuff. So let's try some stuff here. First off, I'm going to make the app blow up by default. So I wrote an exception in here, and as the app runs, it's going to crash. And one of the things you're going to see is we have a brand new exception page that's new to the platform. And the way this works is now I can look at the query, I can look at the cookies, I can look at the headers. We give you a lot more detail than we ever gave you before. I can even click down here and see, show me the raw exception details, and those come out. And so this is a much better page. But what's cool is this is actually, as I said, everything is a component. Here is the diagnostics right here. So you can turn it off, you can replace it. Each of these pieces that you show me hook up, I hook up on stage, are now actually replaceable, and so you can replace any component with your own. So it's not like you're stuck with our old yellow page of death screen that we had before. So let's take let's talk about one more thing here. So notice that it says, is the environment, is it in development? How do we know if you're in production or development mode? The way we know that is you basically tell us. And so I could come over here, and I could add another line. I could say use environment, and I could tell it that my environment is staging. And so if I do that, now this code's not going to run anymore, and I'm not going to get my developer exception page. If I run this, I'm just going to get a blank page because there's no diagnostics because of the way I set this up. Now, I don't expect you to come and change the program and the source code every single time you do this, so that doesn't make a lot of sense. So what we do is we have the ability to actually pick up what environment you're in from environment variables. So what I'm going to do here is took that code out, but I'm going to right-click on my project. I'm going to go to Properties, and under Debug, and you're going to notice that I can set these profiles up for when I run my application. And notice here that I can set these environments. So ASP.NET Core looks for this environment variable called environment, and mine is set to development on my box, which means by default you would get the error page. If I change that to something else, if I change that to staging or something like that, it would behave just like it did before. And so this is how we actually make this work by default. And so this means that every ASP.NET application runs in production by default. You have to go tell it to run in diagnostics mode, either by the environment variable or modifying the code to do that. So now let's take this to the next level, and I'm going to add a file to my app. Let's go add client. We'll add an HTML page, and we'll just call it index.html. There we go. And we'll write some text in here like, hello, this is my first ASP.NET Core application. There we go. Now, if I run this application, and I try, got to kill the exception. Let's go back to startup. If I run this application and try to access that file, I will not be able to do that. So you'll notice it just says hello world. And the reason it does that is because modularity is built in. By default, there is no way to actually serve static files. That's something you have to turn on in the product. So what I'll do is I'll go back to the NuGet package manager. We'll browse, and I'll type in static files. And there's my static file NuGet package. We'll install that. I'll accept that. It restores. And now I can go back to my app, and I can go configure this. So I can say app.use static files. Now if I run the application, this middleware is running, and it knows how to serve static files up. And I go and say index.html. There you go, my page comes up. So this is showing this modularity of the system. And we have lots of these middlewares all set up to basically make your environment act like it would have acted in the old world before. I can also do things like, I could say app.use default files. And if people that are familiar with IS are pretty well aware that you can put an index.html or a default.html in the root of your application, and it will just serve that. By saying app.use static files, I'm actually telling it the same thing again. I'm saying, hey, you can now do that behavior. So if I run the app, then by default, I should get my HTML page that I put in the root of the application. So this is where this modularity, where things just kind of spin in. So let's show one more, and then we'll jump and do a real big application and show what that looks like. So the next thing is, you see I've got this logger factory here. And I was saying before, logging is built into the system all the way at the root. You can see as the app boots up, we're actually wiring some logging up. So, and you'll notice that by default it says it wants to log to the console. That's good, but that doesn't do everything that I need, because typically when you're debugging, I want to see the output of my application in Visual Studio. So I would normally want to be able to look here and see the output from my application. This is all configurable now. And so what I'll do is I'll stop debugging here, and we'll do a couple things. Let's go back to project.json. And you're going to see that my main applications are going to have all this stuff built in, but I'm just showing how you could actually just, from the ground up, build a console application and add capability after capability to build the environment that you're looking for. So let's take our extensions logging console. I'll just clone that, and I will say I want to do debug. And then what this lets me do, let that restore. I can go back to my startup, and I have the ability here now to say logger factory add debug. And now I've got all the logging now will go to Visual Studio as well, because I've told the app to do that. And to prove that, we can come down here, and I could do something like logger factory.create logger. We'll call my logger a demo, and then I will write some information out. The application has just started. And close that out. And now, if I debug the application, I've told the system to actually take my logging and emit it to the output window in Visual Studio. You can see right here. My logging is built in. And the cool thing about all these things is they're all pluggable. So if there's other loggers that you like to use today, you'll be able to plug these directly into ASP.NET Core right from the base up, so you're not stuck with just our logging. You can do other stuff as well. So now let's go do a bigger app. So we'll stop this thing. So on Azure, a customer in the front asked a question: if you're on a server, and a great server to think about is Azure, where would your logging go? We actually have, if you're running an Azure App Service, which is a great place to run web applications in Azure, we actually have a middleware that we're releasing as part of 1.1, which is we just shipped a preview of that a couple days ago, that actually you can basically say use app service logging. And it's pretty cool because what it actually does is it goes and reads the configuration you have in the app service portal, and it will log to whatever you've configured your app service to log to, whether that be a file or whatnot. That's the cool thing about having the pluggability that we have now, is the system's not just built just for the console or just for Visual Studio. We can make it adaptable for where you run it. And so you'll see us in the future, we'll have adapters for virtual machines in Azure. We'll have it for Service Fabric in Azure. You'll have it for Docker. We'll do each of these things. And that's kind of the cool thing about rebuilding some of this stuff from the ground up. So I'm going to build a big application here. So I'm going to say web app. And this will give me a real MVC application. So let that restore. And while that's going on, I'll show you a few things again. Once again, remember these are console applications. The program CS looks exactly like it did for the super small application. But if I go to my startup.cs, which is that class that we tell it to go find the startup class, we're going to see a lot more stuff in here than we had before. So the first thing I've got here is I've got my configuration builder. So I was saying before, we have a new config file, and it will be appsettings.json. And a cool thing about this is JSON file. So the way this works is, as this startup runs, you're going to see this first thing it runs here is it runs this startup method, and it gives it the hosting environment. And what I basically do is I can go and build the configuration builder. And so the first thing I do is I tell it where the app is. And the second thing I do is I can add a variety of things here. You'll see there's two JSON files that I add here. One is I add appsettings.json, and that is the one that I just showed you a second ago. That's my main typical configuration file. And you'll notice there's some pretty cool features here. Notice this reload on change. So it used to be in an ASP.NET application, if you actually change web config, your application reboots. In ASP.NET Core, we actually give you the ability to actually change configuration as your app runs. And you'll notice that it has reload on change set to true, and so the configuration system will actually see that change happen as it happens. Another thing you'll notice here is I say add JSON file, and I give it app setting, and I pass it a parameter, and that parameter is env.environment name. And this is where you would be able to have a configuration file based on production or staging or any of these things. So I could actually, if I wanted to, I could create another app settings. Once again, if we look at the way this worked, I can come here, go to properties, debug. You'll see my environment is set to development. I could come here and create a app settings.development.json, and when I'm in development, it would load that one. When I'm in production, it would run just the regular app setting ones. And then there's something else that's interesting here as well, and this is something we built for Azure as well, but it actually works great outside of Azure. There's also this add environment variables. What I would typically tell a customer to do is not to put your production configuration in your source control system at all, because if you do that, there's a risk that might get out somewhere that you don't want it to. What I would actually tell you is if you have for your production data, your connection strings for your databases and stuff like that, you should do all of that stuff in the environment variables. If you go to the Azure portal for app service, you can actually go to the properties there and actually add environment variables for all your settings. And what happens is if you have an environment variable that has the same name as the setting in the config file, the environment variable overrides the config file, because these things run in the order that I showed these things. So this is, first we're going to run the main file, then anything in the main.development file will override something in the main file, and then finally anything in the environment variables will override that. So the idea is if I have a appsettings.development.json, it'll override my main file. If I have something in my environment variable, it will override that as well. I'm going to make one quick change here. It'll help a demo in a second. So I'm going to rewrite this, rerun this, and I'm going to set this to actually be individual user accounts. It's going to give me a little bit more stuff. Okay, let's go back to startup.cs. So you see how the configuration system boots up. It's restoring packages, that's why it's all squiggled. The next thing that you see here is there's this is my environment development, and if so, builder.add user secrets. One of the things that we've learned as a company is don't ever put, as I was saying before, don't ever put connection strings to databases and stuff in config files, which might end up in GitHub. And so we actually built a feature inside of ASP.NET Core that allows you to actually put things like connection strings. Don't put them in appsettings.json. Don't put them in appsettings.development.json. We have a command line tool where you can actually add things to your local machine, and it stores them in your profile folder. So it's not on the project at all, and it has no chance of getting into GitHub, which I think is super, super, super important. So that's those concepts. Let's go look at the next concept. I was saying before that these applications have dependency injection built into them. There's a method here called configure services, and this is the method that comes up and boots up, and where anything that needs dependency injection to run sets it up. So you can see we're adding dependency injection for my Entity Framework database context. I'm adding it for the identity system, so you can actually log in and do tokens. You'll notice that I actually have one for MVC. And because I built a full application, this application supports logging in with two-factor auth. We need the ability to actually send you an email. We need the ability to send you a text message potentially. And you'll see that we're setting up an iEmail sender and an iSMS sender. And so these are all things that are injected into any of your classes in your application. And to show that, we can go look at, I'll give you an example of this. Let's go look at our account controller. And so the account controller is one of the more complicated controllers in our application here, because it needs to understand users and sign in and email. And so you'll notice here that in this controller, just by creating, if you look at my constructor takes each of those things that we just saw in the startup.cs. Here's my iEmail sender, my iSMS sender. All any of your classes have to do is have a constructor that takes those objects as a parameter, and we inject the type and an instance of the type in for you automatically. So you can see we pass the logging to the controller so it can log. It's got the SMS sender. It's got the email sender. It's got sign in. So this is pretty cool that we can actually put this stuff in your application, and it's built in. Another cool thing as part of that as well, I think it might be in my account controller again, one of my views. Let's see if it's in login. Yes. So not only can we inject into classes, but we also, for the first time ever, you can actually inject objects into Razor files. So you'll notice at the top of this file, I've got this @inject sign-in manager, application user sign-in manager. I'm injecting that into my Razor file, and then if I search for sign-in manager, there you go. I can actually use the sign-in manager. So you can actually inject things like the logger. If you can stick the logger in, and you can call logging directly from the Razor file. So we've really plumbed dependency injection all the way through the app. So now let's show something else. And this is kind of cool. This is one of my favorite features. Is as I was showing on the slides earlier, if you look at the apps that we have today, we had all these different techs: the web API, the MVC, and they were all separate. They all had controllers, they all had actions, but they were completely different code bases and completely different stuff. As I was saying in the slides, now we have one controller that can do HTML, and it can do any other type of data that you want to return, binary data. For compatibility, we have a NuGet package you can add to your application, which will bring in a web API controller, but you don't have to. I mean, we wrote that thing mainly as something to help people convert existing code. So we want to make it where you could basically take your existing web APIs from our web API today and easily port the code. But as you move forward, I think you're going to find that doing this directly in one controller is a much better model, and they all share the same routing and everything else. So I've got this, I'm going to create just a throwaway type here. I need something that maybe has an ID, and then maybe I need, let's get a string, and we'll get a value. So I've got some kind of type here. And the next thing I might want to do is I want to come in here, and I want to write an API. So I'm just write a method here that returns a value. The type we just created, we'll call it getValue, and maybe we'll say it takes an int, it takes an ID, and we'll write some simple code here, return new value, and I'll give it an ID equals ID, and we'll use the new string interpolation here to say value equals value. Actually, it equals ID. Yeah, let's do that. So I basically write a method that kind of returns. Have I not made the system happy? Oh, the value equals. There we go. So I've technically written an API at this point. Before I show this, let's jump back and let's look here one more time. And at the very bottom of my application, after we boot all this stuff up, here's the logging stuff you saw before. In this case, I actually added a few more things, database error page in case your database doesn't exist, you need to run a migration, browser link so you can refresh your page. Notice that for the error stuff, I only have the error page in development. Outside of development, I would just take you to a page that I've got over here. Actually, I think it's under shared. That would be like, hey, your application has an error, please contact us kind of thing. So by default, if you're in development, you get the nice exception page. If not, we take you to a page in your application. You can see we boot the static files middleware up that I showed earlier. We boot the identity up that I showed. And then here's where I boot my controller up. And controllers, my routing up, routing we used to have to define a bunch of types, and now you can see we have this really cool textual string, my controller's home, action equals index by default, and ID is an optional thing there. So the routing syntax is a little cooler than it used to be. But so that's how the MVC got booted up, or the controller mechanisms, I should say, got booted up. So now all I've got to do on my method is I just need to add an attribute, which would be HTTP GET, and inside of that, I'm going to give it what I'm going to call the API. So I want to do whack API, whack value, and then I'm going to pass an ID to that. And at this point, I've written the equivalent of an app that has MVC in it and an app that has web API in it, all in the same kind of application. So let's just see if this works. There are build errors, Mr. Hunter. Let me close this out. Oh, let's just do that. I'll change that to be something else. Change that to be something else. So my MVC application is going to come up. And I can do whack API, whack value, whack 5. And there's my JSON from my API. So I'm showing you that you can merge MVC and web API into a single product in a lot of ways. The next thing is, if you've been using our platform for the last couple of years, we've always had support for what we call test pages. And they were ways that you could actually have developers in your organization. Once you built an API, we wanted to have some pages you could go to that would actually show you what the APIs were, what you called them, what that looked like. We didn't build that in this time around because there's actually great third-party versions of that stuff today. So let's go into NuGet, and I'm going to add one of my favorite packages here. And this will help me bring back all the things that the old templates would have. So swashbuckle. There you go. So swashbuckle is a NuGet package that adds support for Swagger to your application. And where Swagger comes into play is Swagger is a metadata for your APIs. And highly recommend using Swagger, and I'll show you a couple of reasons why. One is I'm going to install this thing. So I've got that package in my application. They got a preview version of Swashbuckle that supports .NET Core, or ASP.NET Core, I should say. It's a better way to say that. And now I've got to write a couple lines of code to get Swashbuckle up. But even before I write that code, one of the things that makes Swashbuckle great is if you've ever used WCF, one of my customers' favorite reasons for using WCF is you write your service, and then you can tell WCF to create you a client app that can call that service. We have the same thing. It's not enabled for Core yet, but it's coming. I can come over here. It won't show in the list, but on a non-Core app, over on my add list, there'll be add web API there. And what that will do is it's a UI that will come up, and you give it the URL of your Swashbuckle, and it builds you a C# class that can call it using a technology in the company called AutoRest that we built. And so it's pretty slick. And as I said, by the time we RTM the tooling, I hope to get that in so you can actually use that. You'll get the full WCF at that point. You can write your API, and then you can then have us generate the C# to call the API, and you've kind of got the whole world kind of working at that point. So that's kind of neat. So let's go configure this thing. So what I need to do is I need to say services. So Swashbuckle wires up just like the rest of the stuff that we have in the product works. And I'll say I want to add Swagger Gen. There you go. So that adds the dependency injection required to make Swashbuckle work. And then down here, I just need to say before I boot the system up, app.use Swashbuckle, or use Swagger. That's going to enable Swagger. And so all that does is, if I run the application again, wait for it to come up. I've now enabled, from that, I can say v1/swagger. That's giving me my Swagger v1. I killed it. Let me try one more here, and then you just turn it all on. Let's do Swagger UI as well. We'll run again. That's what I want. So this is then showing, here's my home controller. It's got a method on it. Here's the stuff that it takes. If I want to actually try it, I can actually pass it a value. I can click try it out. It'll show me the results that come out of that thing. And so by having Swagger built in my application, I can actually try my API out live from Web UI built right in. And so as I said, between Swagger and the AutoRest APIs that we have built in the tool, you basically can get everything back to the point that we were before with WCF. So I want to show one of my favorite features, and the best way to show that is to let me boot up one of these things. And I'm going to build an existing MVC application on system.web. So let's do file new. So we built Razor, the Razor syntax, in about 2010 as part of a push to do let's do that. Perfect. We built Razor as a way to make writing the HTML, the markup that was intermixed with some C#, much, much easier. In the old time, you had a bunch of curly braces, you had to do a bunch of stuff, and we tried to reduce the syntax to it. So we created this awesome Razor syntax, which I really love, and I think my customers like a lot as well. But in the process of that, here we go. So this is what an existing application looks like today. This is the account sign-in page. And if you're writing MVC today, you're going to be very familiar with this. Notice that we've got the HTML helpers here. I've got the HTML.begin form where I pass my login, my account. I've got my validation summary. I've got my label. I've got my text box 4. We thought this was pretty good at the time that we did this. It was better than the model we had before when we were using ASPX pages for this. We started a couple years ago, Damian Edwards and I on the team, we were out at an Angular conference, and he started trying to take some of this code and port it to Angular. So we have an Angular version, and it started calling out some of the problems with this syntax that we had. You'll notice here that if I want to pass some CSS to any of these HTML helpers, the way I do that is I create this anonymous object, which first feels kind of weird. I want to write some HTML, and to write HTML, I've got to create an anonymous object, and then because class is actually a keyword in C#, I have to actually put an @ in class to do this. And of course, I've lost all my IntelliSense for CSS. Mads Christensen on my team builds great CSS editors and HTML editors in VS, but I can't even use those editors because I'm in C#. I'm not in HTML. And so we converted this page to an Angular page, which means I had to add classes and a bunch of stuff to each of the things on the page, and the size of the file just bloated up and got really, really, really big. And so we started thinking about, hey, what's the solution for this? And the solution for this was something we call tag helpers. And so let's go look at the same page that we have today. And the first thing you should see here is the page doesn't look like C# anymore. It looks like HTML. This page does the exact same thing the other page does. So over here, where I had begin form at HTML.begin form, I pass in the parameters, the controller, the method, and some parameters. I do all that in that form. Notice here that I have a form tag helper now, and what I do is, the magic here is when I do ASP dash, that's special, and so we know that ASP.dash controller, I give it the name of my controller, ASP-action, the name of my action, ASP route URL, return URL, so I'm passing the same things as I was doing before, but now I'm doing it with attributes in HTML. Very similar to like how things like Angular and other things do this. But it makes my code look phenomenally great. We go back to the same place over here, HTML.label4, where I want to pass this class with, call md-2 control-label. Look over here. All it is regular HTML. And if I put my cursor in here and I start typing, all my HTML IntelliSense is right here. So we think tag helpers, it's probably my favorite piece of ASP.NET Core, is this tag helper feature that lets me do this kind of stuff. And there's a variety of these things. You can write your own tag helpers. I don't have time to show this, but I think Jeff Fritz has a deeper dive in ASP.NET later today or this week, and he will actually go into more details on that. But you can write your own. And there's a whole bunch of these that we actually have, and I can show you some more that we've got built in. So here's some other cool ones. So we talked about environments earlier on. That's how my logging, not my logging, but my debug stuff was set up, whether I have an error page. Typically in a web application, when you're debugging, you might want to use local files, but you might want to use a CDN, content delivery network, for your files when you're running in production. And so notice that I have a new tag helper here called environment. And what I do is I just pass it a name, And in this case, I pass it the word development, which matches, once again, if I right-click on the project and look at what our environment variable is set to, it's in development. When I'm in development, we emit this markup. And then when I'm in staging and production, I emit this markup. So it's a cool tag helper that lets you decide whether you want markup to be there when you're in production or debugging. Another example of this, maybe you want to include some web tracking, but only do it in production. You would go put the JavaScript for that into this. You'll also notice that we've also written tag helpers for the link element, the link tag in HTML. And so in this case, you see here, hopefully you can tell the dark blue ones means that we found a tag helper for this. And what's different here is I have a regular link here. I say it's a style sheet. I give it a path to my CDN. But what's cool is I now have this fallback URL, this fallback test. And so we wrote a tag helper that actually knows how to say, if my CDN is up, use the CDN. If the CDN fails, and the way I know it failed is I'm going to go try to bring it in, and then I'm going to go do a check to see if I can access a property that it would have added. And if it doesn't work, here's a fallback. And we've got even more of these things as well. There's one that I can come up here and do cache. You know, if you've ever done caching in ASP.NET today, now there's a cache tag helper. And you can say I can tell it when it expires. I can do sliding. I can do a variety of things. And so this tag helper thing makes the markup look a lot better than it has in the past. One final thing on the tag helper side, or the Razor side, I guess, is another thing as part of making the performance awesome and making ASP.NET fast as possible. We wanted to asyncify as much of ASP.NET as we could. And even inside of Razor, you'll notice that we actually support async now. So you can see that as I bring in one of my other views through here, partial async, notice that I can call that asynchronously as well. So we DIified, logified, asyncified all of ASP.NET. So I've got 2 minutes left, so I'm probably out of time for demos and stuff. I'll jump back to the slides. And this kind of shows our current roadmap. We have a 1.1 release of ASP.NET Core that we just shipped a preview for earlier this week. It brings URL rewriting back, response caching back, web listener, precompiled view so your app starts faster, and it's got that Azure integration I was telling you, the gentleman in the front row. Next year, early next year, we have WebSockets coming back, SignalR coming back, Web API security coming back, Razor pages. This is very similar to the old web pages stuff. You can actually write an MVC, your markup, and your controller in the same file. This is coming out sometime early next year, and that is us. So if you want, we're on GitHub, github.com/ASP.NET/home. You can read all about us. I was mentioning before we have docs.asp.net to find the docs on this stuff. And then we have what we call a community stand-up every Tuesday typically. Some of the team, you can go to live.asp.net, it'll have the schedule, and some of the team comes online and talks about what we're building, how we're building it, and even answers questions and stuff from Twitter and stuff like that. So I really recommend hitting one or two or three of these things. If you have any more questions about ASP.NET Core before you leave, please come up and see me. Thank you guys very much.